Hi, welcome back. This is a quick tutorial on doing a bit of reflow soldering with nothing more than a toaster oven. I happened to be at the local hardware store a few weeks ago and managed to pick one up at almost 50% off. Brand new toaster oven with convection. So I will be having a go at reflow soldering some LED addressable lights onto this board here. So what this board takes are the WS2811 LED chips. So I have a roll of them here. They're got them from eBay, and they come in these little packets like this. So they have 6 pins on them. The newer ones, the WS2812s, only 4-pin variety, won't work with this board. It's what a friend of mine designed early last year, and it works quite well. And you end up with a board like this with the LEDs on, and on the back of it you put your capacitors, and he originally had some resistors in there as well, but you actually don't need them for this, so I just have a solder bridge across those. Capacitors are just for decoupling. You can actually daisy chain these boards, data in, data out, to the next board, data in, data out, etc. if you want. Also, there's room on the board, if you so desire, to put a AT Tiny 85 on here and drive the LEDs from that as well. There's a little programming header as well as a standard kind of interface for talking to the boards. This cable at the end here, that's so that you can drive the data in from a separate Arduino Uno or something like that, whatever you really want to use it for. So there's 10 lights on the board, and the first time I tried doing this with a regular soldering iron, I destroyed more LEDs than I managed to solder on, which wasn't very good. They melt very, very easily if you've got the soldering iron too high, and of course, you know, it's just not easy to solder them. So I figured that I would try using the reflow oven to do it. Now I haven't modified it yet with a controller, so I'm just going to give it a go initially just using my Agilent U1273A to monitor the temperature and just adjust it by hand, just for the sake of getting these done, because I'm going to have a whole separate project to modify it to put a better 3-term controller in there and things, but it's not ready yet. So when you do reflow components this way, what you use is a paste solder. So the way this works is you put solder paste, which what I have comes in a tube like this, usually used for automatic machines to inject it in. I'm just going to be pushing the end and putting it on by hand because I don't have any automatic machines. It's got the flux and the solder, basically a solder powder, all in one tube, and you just squeeze it out and put it onto the places where you want solder to be. Very important to have a good solder mask on your PCB so that it doesn't bridge joints and everything. And you have to heat it in a certain way. So here's a typical profile for regular lead solder, which is you ramp it up to the soaking temperature at about 1 to 3 degrees centigrade per second. Once you're at the soaking temperature, which is where you allow the whole board to warm up fairly evenly, which is about 150 degrees centigrade plus or minus 20, you keep it there for up to about 2 minutes. Once you've gone through that period, then you ramp the temperature up to about 217 degrees centigrade. What this will do is actually melt the solder, and basically everything will then connect up as if you've been using a regular iron or something. The only difference is you're using a very controlled temperature, and you don't want to go too hot so you don't melt any plastic components or anything like that. And you stay there for about a minute, so 45 to 75 seconds. You stay at the melting temperature, and then you bring it down at about 2 to 4 degrees C per second. Now everything I've seen for this, really people just pretty much ramp it straight to the liquidus temperature of 217, and then leave it there for a minute, and then they basically just turn it off and open the front door of the toaster oven to let it cool down naturally. You don't want to force cool it because you cause extra stress on the components and things that are going to be on the board. What I'm going to do for this first test is I'm going to bring it up to about 150 degrees centigrade and then hold it there for a minute and a half, 2 minutes, and then I'll just change the temperature to up to 217. Now, I did a test with my oven before and it does go just a little bit high, so I'll probably set it for about 210, 212 or something like that, just to allow for overshoot. Let it run for the minute and then let it come down again. Now, so I don't waste a whole board, because I've seen people toast these things in the past. These boards are V-notched, so I'm going to break one of them off and I'm just going to do the one thin strip. That way, if something does go wrong, I'm only going to lose one board and one set of LEDs. If this is a success, then I have 2 complete boards. One is a 7 by 10 and the other one, what's left, is 5 by 10. So this is going to make quite a nice little full RGB matrix panel for me to play around with for the Internet of Holiday Lights. And well, let's see how we go. First thing you want to do with these is make sure the board is clean. So what I have is a bit of isopropyl rubbing alcohol. You can just pick this up at the local chemist or pharmacy, depending on what you call it, from depending on where you are. This is just to get rid of any contaminants on the board before we start putting things on, because you want to give it as good a chance as possible to everything to flow properly. So I just put a little bit on a cloth. I actually have previously cleaned these, but it was a couple of days ago. So I'll just give it a wipe over all the contact areas. Now this stuff evaporates quite well itself, and that's pretty much it. And the next step is going to be to put some solder paste on each of these contacts where the LEDs are going to go. Now this, because I don't have a proper applicator, I'm just going to use a small flat-bladed screwdriver and just gently dab it on. You really can't go overboard too much with this, because there's a lot of flux in the paste, and as long as you just get it just about enough, even if there's little bridges across, when it melts, it will actually the surface tension will actually pull it onto the pads and should prevent any shorts from occurring. So let's get to putting the paste on. Okay, we have a little bit of solder put out. Just going to zoom in a little bit. Hopefully my arms are not going to get in the way too much, and I'm just going to gently put bits of solder. As I said, this should reflow itself nicely and separate, even though I've got little lines of this, but that's why I'm only doing one to start with, just to make sure it works properly. It's literally the first time I'm trying this, so this is just an experiment. The right way, of course, to do this is with a stencil. I don't have one. So if this works, that'll be great. If it doesn't, well, I'll have to try some. You can see with these LED chips that they have a tiny little notch on the corner of each one of them. I've orientated these so they're all the same way, and what that indicates is pin 1, because there's a microchip in here and things, and of course even LEDs. There is a right way and a wrong way to put them on, and if you compare to the board that I have not put a solder mask on, you'll see that the pin 1 is on this top left corner of each of them, signified by the dot on the solder mask. Okay, so this is orientated the same way. So I've got all the LEDs lined up, and the trick here now is just to gently pick them up and drop them on top of the solder paste, getting them roughly lined up. Now, even if it's not perfect, the theory is that the solder, when it goes fluid, the surface tension will actually pull the chips into the correct place. So even if they're slightly off, it should be okay to do the reflow with, because it will just correct itself. So we'll find out. Of course, it still pays to try and get them on as close as possible, because if they're too far away, then even surface tension won't be able to correct for that. But if you're pretty much on the pads correctly, even if it's a little overhang, then it should be fine. So these LEDs, because they have so much plastic on them, that's one of the reasons why I was having a lot of difficulty hand soldering these. Now, I'm not sure if I've overdone the solder paste here, so I guess we'll find out very shortly. Okay, so that's just all there is to it. The other side of the board is where the resistors and things are going to be put on. but of course I can't reflow both sides of the board, and the one that I have trouble with the heat is the LEDs. So I'm going to use the reflow oven to do the LEDs, not the resistors. So as you can see, this is just a regular Tefal convection toaster oven. I've got it set to the convection dial, and according to the sheet here, the pre-soak value is 150 degrees centigrade. So I'm going to crank this down to 150. I've got my fluke here, which I'm going to use to monitor the internal temperature just in case. Right now it's at 20 degrees, which is what the temperature is in here. Just move that around just a little bit. Now I don't have any light inside the toaster oven, so I'm not going to be able to show you this thing actually doing its work. I do have a thermocouple that I'm going to use, so I'm just going to gently weave that a little bit into where I'm going to place the board. That way I have a fairly close idea of the temperature that it's going to be. So there's the probe in place. I had my fingers on it, that's why it's showing a bit warmer right now on the temperature gauge. So we'll take our board, and what I'm going to do is I'm going to sit the board just over the top of the thermocouple without touching it, and we'll just slide that back in gently. There we go. And that's all set to go. 2 minutes. The camera has a timer on it, so I'll be able to monitor that. And we'll see how we go. So let's start it any second now. Okay, we've just started it. It's just starting to warm up, so it'll take it a few moments to get up to temperature. As I said, we're just monitoring this on the temperature probe here on the Agilent 1273A. These are nice little multimeters because they actually come with the thermocouple probes right out of the, it's just a standard kit that comes with them, so you don't have to go buy these as extras. And the accuracy of those is pretty good as well. So the tip here is sitting just marginally above the board that we're reflowing, so we shouldn't have too much of an issue. We're up to 43 degrees centigrade. We'll just let that get up to 150 and I'll be right back. So my toaster oven is just kicking out there thinking it's 150, but it's actually only 140, so I'm just going to crank it up just a little bit more. Start timing from now. Got 2 minutes at this temperature before we go up to the reflow temperature. Okay, that's a minute so far. Now, if you remember on the flow chart here, it actually says that the pre-soak is 150 plus or minus 20. So we're actually on the higher side of the pre-soak just because of the crudeness of the temperature control on here. I actually cranked it back down to 150, but it's still sitting there nearer 170. So that's a toaster oven for you and how accurate they're not. One of the reasons why this will get modified at a later date to have a nice proper temperature controller in here. So that's a minute and a half now. So what I'm going to do is I'm going to take it up to 217, hold it there for a minute, and then I'm basically going to turn it off and let it cool down with the door open. Okay, that's now 2 minutes, so I'm going to crank the temperature up to 217-ish degrees. So that's going to take a few seconds to ramp up there. Once it gets there, we will time 60 seconds and then take away the heat. So I can't see whether it's reflowing or not inside yet. Nothing seems to be melting, which is a good sign, of course. I can't see it reflowing yet either. But that's what you have the liquefy stage for. That's where everything should convert into a solid solder and the flux should basically evaporate away after having done its job. We're up to 185. We probably should start seeing things change state anytime now. If I can, yep, I can actually see the solder blob starting to form now on the components, bubbling up quite nicely. Hopefully I don't have too much solder on there. Looks like I probably could have done with less. Okay, that's sitting at 210. Let's start the timer. That's 30 seconds now. And that's the minute, so let's just turn it off. And open the door to let it cool down of its own relatively quickly. I said cool down is about 2 to 4 degrees C per second. So that's quite a rapid cool down. And as you can see, that's doing it quite happily itself. So I'll come back when that's cooled down to a temperature that I can touch. It's a close-up of the board. It's still a little bit too hot to touch, but it doesn't look too bad. Once we're done, I'll put a macro lens on and we'll have a close look at the pins. Well, I guess that answers that question. There's just a little bit too much solder on there. So while some of the joints seem to have done reasonably well, there's a few that have got little solder bridges on, so I'm probably going to have to use my small iron and try and remove a little bit of that. We'll do this again. Much less solder paste this time, and see if we can improve that somewhat. I think it looks like most of them I've actually done okay. A few little splats where I had the too much paste, but yeah, I got about half a dozen bridges here to clean up. So let me just get that cleaned up on this one, and then we'll give it another go on another strip. So what I'm using here to clean this up is a strip of fine soldering, desoldering braid. It's got flux built in, and it's basically just a woven copper strip. So I can do this without blocking all the light and keep it in camera shot. So you just heat it through the copper braid and it will soak up the excess solder from the joint. Don't leave it there too long, otherwise you're going to heat up the component too much. But that's pretty much all it takes to do that. That's now under my microscope here. It looks like it's pretty good. So I will just do the rest and get back to you. So just quickly finished cleaning up the strip. I can't see any more bridges across it. Of course I can't test underneath the strips. I did a quick measurement through the strips with a meter just to make sure that the basic set of pins were connected to what they needed to be, and that seemed to be okay. So what I've done is I've quickly programmed an Uno here with a light strip test from the NeoPixel library from Adafruit, and told it it's got 10 pixels, so let's see if this thing works. Now I haven't had to replace any of the neopixels in here yet, so hopefully this will be just fine. And there we have it, all 10 working. So excellent. Lesson learned there. Obviously we need to use less solder paste. So what I'll do now is I'm going to solder up the other panel. I won't bore you by taking you through all of it, but I will show you just before I start soldering it, and also when I'm done, to see that I've put a lot less solder on there. And we'll give it another go in the toaster oven. So, be right back. So this is the next board I'm going to tackle. It's got 5 rows of 10. Just going to clean it up, get all the solder paste on, then I'll be right back. So, been experimenting with the best way of putting the solder paste onto this, and if I can do it without getting the magnifying glass in the way, because this is very hard to do without something. You can see here I've got a needle that I've been using for refilling ink cartridges. I put that on the end of the solder paste here, and now if I just gently squeeze on the syringe, I can put controlled amounts of solder onto the pads a lot easier than trying to dab it with a screwdriver or something, which makes this thing go a lot quicker. I think it might still be a bit too much, but we'll find out soon enough. Okay, I'm going to finish the rest. So here's all the soldering done. I haven't put the capacitors on yet, but they seem to all be working. So let's just give it a quick shot. This is the board that I had done earlier, sitting here, and this one is going just fine. I have noticed that the very first pixel right here on this first one, the red LED in it seems to be faulty. The green and the blue seems to be working fine, but as you can see, the red is not working there, so I may replace that one just with a hot air gun. We'll see how that goes. I've got another board to make up first before I decide whether to do that or not, so if I have any spares I'll replace it. If not, I'll just leave it working with green and blue and be done with it. Anyway, it just shows that as long as you don't go overboard with the solder, the reflow oven works quite nicely. So that's it for this quick demo. Looks like I will be creating a proper profile temperature controller for the oven at some point in the near future, but this is another board made up and ready for the holiday lights, and we'll get them paired up with probably the Arduino Mega as its lighting show with some decoration somewhere. Maybe accompany it with some music or something like that. We'll just have to wait and see. Anyway, that ends the video, so glad you could watch. Hope you learned something. Never too late to learn a new trick. As I said, this is the first time I've ever done any reflow soldering in an oven, and I didn't use a proper controller yet. I just simply used the oven as it was with a decent meter just to verify the temperature and stopwatch, and it works just fine. Just don't overdo the solder, as I did.